Hello and welcome. This is question 5 of the Phys 101 Princeton Physics Final Exam. My name is Jerry and I'm going over the problems in this exam. Now this is problem 5 and let's just get to it. A piece of ice at a temperature of 0.0 degrees Celsius with a mass of 100 grams is converted into water at 0.0 degrees Celsius. What is the change of entropy in this process? And it says the latent heat of water is 33.5 times 10 to the 4 joules per kilogram. So those are our knowns. We see that the temperature is constant, we have the mass, and we have the latent heat. Specifically, this is the latent heat of fusion. There's a difference in the latent heat of vaporization as well. I'll go into that a little bit more in a second. And we also have these two equations. We have the change in entropy is equal to change in heat over temperature. Over time, temperature, not time. You can find that at the bottom right, middle right actually. You can see that equation, and the other equation is in the kind of middle left, a little bit below. Q equals ml. Okay, so let's see what we have to do. Now, because we have these two equations, we can know that change in Q is simply equal to Q in this case. So it really is quite trivial. We can say Q, not Q, we can say ml over T. Now, the reason that we are using L is because this is a phase change. This is ice turning to water. That phase change is basically it happens when temperature is constant, well, generally, and the latent heat is the amount of heat energy required to affect this phase change. It's specific to each compound. Like I mentioned earlier, this is the latent heat of fusion, so going from ice to water. It'll be different, say, when we're going from water to gas. That's called the latent heat of vaporization. But that is not of importance right now. All you have to do is plug in the numbers and what you get, what you should get. Oh, I guess one other thing to mention very quickly. The temperature is not, well, it is 0 degrees Celsius. 0 degrees Celsius is 273.15 Kelvin, which is also shown at the bottom left of this constant equation sheet. So after you plug all this in, you should get about 122 joules per Kelvin. Now, thank you for watching this. There'll be many more videos to come.